Let's try this question. We need to find the derivative of this function. We're not allowed to use our rules for derivatives. We only are allowed to use the definition of the derivative. If we were allowed to use the rules for derivatives, I think we would know right away that the derivative would be, what, 8x minus 5, right? But pretend that we're not allowed to use those rules, and we have to derive it from scratch. So what is the definition of the derivative again? Well, it's a limit, right? Excuse me. F prime of x is defined to be, the limit as h goes to 0 of f of x plus h minus f of x all over h. Now let's see what this becomes. I think the only real tricky part is, what do you replace f of x plus h by, right? Well, the way I think about that is you certainly don't have to write this down for your own work if you understand it already, but I'll just write this down in case you don't quite understand. So f of x is equal to 4x squared minus 5x, right? How about instead of writing the x, I just write an empty box? So f of anything is going to be 4 times that thing squared minus 5 times that thing, okay? In this formula here, in this box, we have an x. But you really can put anything in there. You could put the letter p in there. You could put a very complicated formula in there. It doesn't matter. In this formula, we're required to put x plus h in there. So let's do that. So f of x plus h is really 4 times x plus h all squared minus 5 times x plus h. So in some sense, I just replaced x by x plus h. So it isn't that hard. And that makes up this expression here, f of x plus h. I still have to minus off f of x. Just to make things look clean, why don't I put brackets here? Minus. And then inside those brackets that I just made, I'm going to put what f of x is, namely 4x squared minus 5x. And then it's still all over h, right? Okay, good. I'm going to erase this now because we don't really need it. Again, you don't have to write any of that, of course. I just put that there to help explain what f of x plus h is in this case. All right, so let's keep going. Notice how each time I write the limit sign, that's pretty important. A lot of students, they forget about that, and it's really, you can only drop the limit sign at the end when you actually do the limit. So x plus h squared, I think you guys should know that it's x squared plus 2xh plus h squared. Foil that out if you don't know that. And I'm not going to bother writing these brackets here. This 5 here multiplies onto both. So we get minus 5x minus 5h. And this minus sign applies to both of those as well. So this is minus 4x squared plus 5x. And it's still all over h. Notice I cannot put h equals 0 inside of this expression because on the bottom I would have 0 then, and that's no good. What we hope is going to happen is that everything in the top, we're going to have some really nice canceling in the top, which is going to allow us to cancel off the h on the bottom, and then after that we will be able to put h equals 0 in. Let's get rid of these brackets too. Maybe I should have done that on the last step, but it doesn't matter. And the rest of the stuff I'm just going to recopy. Minus 5x, etc. And that is all over h. All right. Now I talked about some nice canceling. Let's see if we do. Pretty much any term on the top that does not have an h in it should cancel off. Let's see. 4x squared minus 4x squared minus 5x plus 5x. And I think that's all the canceling we can do. we're left with 8xh plus 4h squared minus 5h all over h. Alright, so I think it's, remember, don't do something like this, right? That's wrong. We need to, we actually need to cancel an h, a single copy of h from all of those terms, right? If you're a little bit uncomfortable with that, I would suggest, first of all, just factor out a common factor of h on the top. Obviously, h is in every term, so we can factor an h to the front of that using common factoring. And now we're allowed to do that kind of canceling that was temptation, that we were tempted to do before there. And why don't I write the expression? And now, since that h in the bottom is gone now, there is no more denominator. Or in other words, it's over 1. And now I can actually let h be 0 in my expression. Notice I don't write the limit sign anymore, finally. And I come up with 8x minus 5. And that's what I said at the beginning the answer would be, right? So, I erased it. But anyways, the derivative is 8x minus 5. So we've just used the definition of the derivative to find the derivative of that function. Of course, it's much nicer just to use the rules because you get the answer in 1 second instead of having to do all this work. But it's still important to know how to do this because on exams, there's always at least one question that asks you to find the derivative by only using the definition of the derivative.